14.5, write trigonometric functions. Math is clearly the language of love. And here's the graph of 1 minus sine theta, though it's on the polar coordinate system, which we're not going to be doing this year, but I'm going to do something fun at the end of this lesson related to this. What we are going to do in this lesson is be talking about sinusoids, which are just the graph of sine and cosine functions, which we've been doing all along, except that we've typically been given the equation and been asked to graph it. And now they're going to show us a graph, and we're going to have to come up with the equation. So we're just going to be going backwards here. Remember, something really important is remember that the b is always factored out. You don't want anything to be touching the x. Remember, a little hint I gave you was that the parenthesis should be hugging the x. So make sure that the parenthesis is always hugging the x and that that b is always factored out. So don't forget, parenthesis must be hugging the x. In this question here, they ask us to write the function, so let's see what we want to do. And there's multiple answers for this question also. There's not just one right answer, but I'm going to go with cosine, and I'm going to pick up this period right here, I think, because I see that's clearly a period, and I know it's cosine because I'm starting up, and so that would be the graph that looks like cosine. Of course, this is shifted over. So we're going with cosine here. So I'm just going to take a note of that. What else are we doing? Well, let's look at the period first. Let's see. If this is pi over 3, then this would be 2 pi over 3. And then this would be 3 pi over 3. Because I just concluded that 2 tick marks was pi over 3. So this must be pi over 3, 2 pi over 3, 3 pi over 3. And of course, 3 pi over 3 is simply pi. And so the period would just be from pi over 3 to pi, which is 2 pi over 3. What's my amplitude? My amplitude is, I went up 2, all right, so the amplitude's going to be 2. Let's also look at our phase shift and our vertical shift. Our phase shift, we're starting at pi over 3, so we're going to say the phase shift is pi over 3, and the vertical shift, well, there is none. We went up 2 from here, and we went down 2 from the 0. Okay, so there's no vertical shift. Now remember, when I write this, I want it of the form y equals a cosine, and then b x minus, I forget what letter they used. Oh yeah, the h and the k thing. It really doesn't matter. Just remember that it's your transformation, just like we've been doing all year long. But what we really need to do is identify what this b is. So think back, we're undoing everything that we were doing before, right? So before, you determined that since cosine, the normal period was 2 pi, and then you undo all of the stuff that's related to the x, then 2 pi over b should be equal to your period, right? Well, now we're given the period. Now we know that 2 pi over 3 is equal to the period. So that must be equal to 2 pi over b. Well, this one's pretty easy. 2 pi is in the top in both of these, so b must be equal to 3. So I know my b is 3. So I have y equals, the amplitude was 2, cosine, the b is 3. Then we have x minus, what was the phase shift? That was just pi over 3. And then the vertical shift was nothing, so I don't need to write anything. So this right here would probably be my preferred answer. If you had written y equals 2 cosine 3x minus pi and just distributed out that 3, that would have been acceptable also. I'll tell you, my first intuition was not actually this one. I thought this would be easier to explain. My first intuition was picking up this right here, okay, the blue. You see how that's a period? I start down there and then I end up down there again. That would be one period. And so let me just do this one for you also. This one, since it started down instead of starting up, I knew would be negative cosine, something to do with negative cosine. Again, my amplitude would have simply been 2 because I went 2 this way and 2 that way. And my period would have been, let's see, I went from 0 to 2 pi over 3. So my period would have been 2 pi over 3. Of course, I should be finding the same exact stuff that I found there. In this blue one, though, my phase shift is going to be 0 because I start right at 0, and my vertical shift is also going to be 0 because I just go down 2 and up 2 from the 0. Okay, so again, since my period was 2 pi over 3, remember that means the period, which is 2 pi over b, must be equal to 2 pi over 3. In other words, b still equals 3. But now what I'm going to be doing to write this is I'm going to say y equals, since I was basing it off of the reflection of cosine, I'm going to have negative 2 cosine, and then I have the 3x, and there's no phase shift, and there's no vertical shift. And so this is going to be my final answer. This is equivalent to this. You could have also written one that went with sine if you had started here, okay? So I can't just accept one answer on these. There's going to be a lot of different answer possibilities. You just pick the one that's most obvious to you. All right, let's see what's going on in this one. A physical therapist recommends an exercise for a patient recovering from shoulder surgery. The patient extends his arm and rotates it in a circular motion. At the highest point in the circle. Okay, so the person's going to be rotating their arm in a circle. At the highest point, all right, here's my axis. At the highest point, the patient's arm is 65 inches above the ground. His arm is 40 inches above the floor at the lowest point. So he goes from 40 inches to 65 inches. His arm makes 4 revolutions per second. So 4 revolutions per second. Write a model for the height of the arm as a function of time if the arm is at its highest point when t equals 0. Okay, because it's at its highest point when t equals 0, that tells us what type of curve we need. We know that we start high and then it goes lower like that. And the highest point is 65 and the lowest point we ever hit is 40. So clearly it's going to be a cosine graph, right? Because it starts at its highest point. This right here tells us it's going to be a cosine graph. Okay, so we're dealing with cosine. Now, what's our amplitude? Let's think about it. Our amplitude is simply half of the highest minus the lowest. So our amplitude is going to be 65 minus 40 over 2, which is 25 over 2, or 12.5. Our amplitude is simply how much you go up from the center and how much you go down from the center. What else do we need to know? We need to know our period. Okay, remember the period means how long does it take to complete one cycle? Well, what do we know? Well, we know that we go 4 revolutions per 1 second. But a period is just one cycle, not 4 cycles. 4 revolutions would be 4 cycles. So that means that I go 1 revolution in 1/4 of a second, right? Because I divided by 4 on the top, so I divide by 4 on the bottom, and that's fine. So that tells us that our period is simply 1/4. Again, how long does it take to go 1 revolution or 1 cycle? 1/4. 1/4 a second. All right, so now let's figure out what B is. We know that 2 pi over b is equal to the period, which is 1/4. And so we have b equals 8 pi. Okay, so we're going to use that information. We're going to use the amplitude. What else do we need? We need a phase shift and we need a vertical shift. So the phase shift, well, we're just starting it right at t equals 0 at our highest point, and this is going to be our cosine graph, and it looks normal, like a normal cosine graph, so we're going to say the phase shift is none. What's the vertical shift? Well, where is the center of this guy? It's halfway between 40 and 65. So what's halfway between 40 and 65? That's just the average of 40 and 65. Well, that is just halfway in between there is 52.5. So that's going to be my vertical shift. So my equation just becomes y equals amplitude 12.5. We had a cosine graph, cosine, and then our b is just this 8 pi, and then we have x minus phase shift, which there was none, so I didn't even need that. So I just have 8 pi x, and then plus 52.5. That's our equation. This might seem like a lot, but you just take it one step at a time. Just think it through. Think, what's your amplitude? Remember the definition of amplitude. What's your period? How long does it take to complete one cycle? What's your phase shift? Well, since I started high, that's just a regular cosine graph. If I had started low, that would have been like what we did in the previous example. If I had started in the middle, that would have been just a sine graph, right? And then what's your vertical shift? So where is the center of this thing is what you're looking for. And that's how you come up with the equation. Now, before I close this lesson, I just want to have a little bit of fun, and this might come in handy for Mother's Day. Maybe my mom will be watching this video. A shout out to Mrs. Roshan. In order to graph this and for it to come out like this heart, go to mode, and instead of graphing a function, we're going to graph in polar. Now, we're not doing that in this course, but you will do it next year. So let's go to polar. Okay, and if you go to y equals, you'll see that it says r equals. That's for the radius. And let's just type that in, 1 minus sine. And you'll see that when you go to press your x, it turns into a theta. That's why it always says the x, t, theta, n. It depends on which one of those things you chose. And then go ahead and graph it. And you can't really see anything, so let me change the window a bit. The window I've been playing around with is negative 1.5 to 1.5, and then for the y's, negative 2 till about 1 works. And make sure you don't change the theta. What the theta is actually doing is you'll see that 0, and it goes to 2 pi, because that's one time around the circle, 0 to 2 pi. You see that? You probably don't understand that, but I don't have time to get into polar coordinates. Let's just graph this thing. And there we go. You could play with the window a little bit. Maybe I should have just made the y max be like 0.5. It's probably going to look a little bit better. Yeah, that looks better. And then I'm going to show you how to draw something in the middle of it. Go to second, draw. And if you go down to 0, you'll see text. And what you can do is just go put your cursor wherever you want to start typing. So I'm going to do it right there. You, and then I'm going to put mom. And so you never know, that might score you some extra credit with your mom or your math teacher. And that's it for this lesson. Bye.